Hi guys, this is the main project work, extended period simulation of water distribution system. Our project consists of environmental stream in which we choose water supply system. In the water supply system, we take maintenance aspect for our project. That's through simulation process, we take extended period simulation. The satellite image of a project location pointing the water source available. The aim of our project is to develop a model for an existing water distribution system to study the hydraulic behavior of the model. The scope 1 of our project, actual system is not disrupted. We can save time and money. Results are easier to visualize. The methodology of our project is site investigation, GPRS survey, network model, simulation, and at last validation. The zone and consumers of our project. Totally we have 4 zones and the total consumers are 9968 consumers. The junction demand. We have 4 campus and so we have 4 zones and each have their own water demand. The hourly hydraulic pattern of our water distribution system using the college campus. This is the daily hydraulic pattern of our water distribution system, and weekend we have less water consumption. This is a monthly hydraulic pattern and we have less consumption during the winter and more at summer. The reconnaissance survey of our project consists of reservoir, tank, junction, pipe, pump and control valve. The GPS survey of our project is used to locate latitude and longitude of each component of the system. This is a L1T1, a tank of a water distribution system model. The zone 1 of the network model consists of a reservoir 1. Through the reservoir 1, we take the pipe to a pump. The pump is to take the pipe through to the tank through a gate valve. The gate valve takes the water to the tank T1 as you see in the slide. Through the tank 1, we take the water to the another tank T2. And at last we take the water to the junction. North direction is mentioned in the picture. We use the software WaterCat V8i to model it. The zone 2 of the network model has again a reservoir. Through the reservoir, we take the water to the pump. And from the pump, we take the water to the gate valve. You can see it in the picture. From the gate valve, we take the water to the tank T1. From the tank T1, we take again to T2. We have 2 tanks in the picture. And from tank T2, we take it to the junction. The junction has the consumers who take the water. The zone 3 of the network model has its own reservoir L3R1. From the L3R1, we take water to the pump. From the pump, we take the water to the gate valve V1. From the gate valve V1, we take the water to the tank T1. In the zone 3, we have only one tank available. Through this tank, we take the water to the junction. The north direction is upward in the zone 3. The zone 4 of the network model has zone 4 reservoir. From the reservoir, we take the water to the pump. From the pump, we can take the water to the gate valve V1. From the gate valve V1, we take water to the tank. In the zone 4, we have 3 tanks. So first, this pipe takes the water to the tank T1 and next to the tank T2. And from the tank T2, we take the water to the tank T3. And at last, the water from the 3 tanks will be consumed by the junction L4J1. The WaterCat VLT software, we have the pipe properties. It was listed using the flex table of the software, and the current time used is 10 hours. Pipe properties, we have number of pipes 29, material PVC, diameter 2 inch and 2.5 inch, and length is auto scale. The junction table, the current time tier 10 hours. We have you can see the elevation of the junctions. Tank properties. In the tank properties, we can have elevations, volume and diameter of the tank. In the pump properties, we have the elevation and the status. The initial status is on. Definition of 5 horsepower pump used in zone 1, 3 and 4 can see the flow versus efficiency curve and flow versus head curve. Similarly, for definition of 7.5 horsepower pump used in zone 2, the curve is drawn. Condition sets. We have 2 types of conditions, simple control and logic control. The simple control is based on the hydraulic gradient line in the tank and the status of the tank on and off. The logic control is based on time greater than or equal to 7 am or greater than 6 pm. Calculation summary. You can have the volume stored in the tank, the volume flow and the volume supplied. The flow velocity of the pipe L1P3 for 24-hour duration. This is one of the type of result. The other type of result we have in the tank for 24-hour duration L3T1 net outflow. Next, for the same tank for 24-hour duration we have the percentage full. So we know the capacity of the tank has not reached beyond 100%. The volume of the tank stored in the same L1T1 tank for 24-hour duration. The flow of water through a pump L2P1, that is zone 2, for 24-hour duration. So, and at last we have the conclusion. With our model and the maintenance process, we can take this water distribution system as a maintenance aspect and supply to the water to the consumers. These are our references for the project. Thank you for watching. For more, subscribe to our channel. Thank you.